Hey guys, we're going to talk about binary or base 2 in just a second, but let's review some things we know about base 10. Base 10 is the numbering system you and I have grown up with. It has 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we can count as high as we want with these 10 digits. Now what comes after 9? 10. Well, why? What is a 10? What does it stand for? Let's take a look. The 0 in 10 stands for 0 ones. The 1 stands for 110. Why? Because this column here in base 10 is the ones column because 10 to the 0 power is 1. This column here is the tens column because 10 to the first is 10. Well, let's kind of keep going in that direction. What about 4,376? Well, we have 6 ones, 7 tens, 3 100s, and 4 1000s. Why? We have 6 ones because the first column is the 10 to the 0 or the ones column. We have 7 tens because the second column is the tens column, 7 times 10, 70, or the 10 to the first column. We have 3 100s because the third column from the right is your 10 squared column. That means that the value here represents hundreds. And then we have 4 1000s because that's 10 to the third or the 1000th column. Okay, let's talk about binary. Binary has 2 digits, a 0 and a 1. And by the way, these are pretty good at representing the state of electricity running through a wire. But more on that later. We can count in binary too. We can count from 0 to however high we want to go. But for right now, I just want to count to 10. So here's in red, 0 and then 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9 and 10. So why? How does that work? Well, this is the ones column in binary. Right here I put a small 1. This says we have 0 ones. That's a 0. And here I have 1, 1. That's a 1. Well, how do I represent something that has a value of 2 in decimal, but in binary? I have 0 ones and 1 2 because that's the 2 column. 0 ones and 1 2. Well, what's a 3? It's 1 1. I have 1 1 and 1 2. Add them up. 2 and 1, 3. What's a 4? No ones, no twos, and 1 4. What's a 5? 1 1, 0 twos, 1 4. Add up a 4 and a 1, that's a 5. 1 0 1, that's a 5. This is a 6, a 4 and a 2. A 1 1 0 is a 6. No ones, 1 2, 1 4. A 7 is a 1 1 1. 1 1, 1 2, 1 4. An 8 is no ones, no twos, no fours, but 1 8. A 9 is 1 1, no twos, no fours, and 1 8. 8 and a 1 9. And a 10 is no ones, 1 2, no fours, and 1 8. An 8 and a 2 is a 10. Okay, so notice that the column on the right, this one is worth 1, then 2, then 4, then 8. And if we keep going, 16, 32, 64, 128, 256, 512, and so forth. Okay, so let's talk about this just a little bit. Here's base 2. If this was my decimal point here, okay, assuming I have a whole number, everything would be to the left of the decimal point. 1, 2, 4, 8, 16, 32, 64, 128, whatever. You can go as long as you want. Well, why is this a 1? Well, this is base 2. And 2 to the 0 power is 1. Why is that a 2 right here? 2 to the first power is 2. Why is this a 4? 2 squared. Why is this an 8? 2 to the third. 16, 2 to the fourth. 32, 2 to the fifth. Okay, let's take another look at this. 1 0 1 0. That would be equivalent to a 10 in decimal, in our decimal base 10 system. Well, why? I have 0 ones, I have 1 2, 0 fours, and 1 8. Add the 8 and the 2 together and you have a 10. Now, how does binary help us store data? Okay, we store data, sorry about misspelling there, sorry about that. We store data in main storage using electricity. If you recall, in a machine that has 16 gigabytes of storage, that's 16 billion characters that you can store because you have 16 billion storage locations. Each storage location has 8 wires or bits that can either have or not have electricity running through them. And it's these combination of 8 bits or 8 wires that create a byte which can store a character. Now let's sort of go back and review. Here's one storage location right here, one of our 16 billion. And inside it, I have 8 wires. This one, all these, here's 8 wires, 8 bits. This wire is worth 1 if it's on and 0 if it's off. 2 are 0, 4 are 0, 8 are 0, 16 are 0, 32 are 0, 64 are 0, or 128 are 0. Capital A is a 65. What's that mean? Turn on the 64 and turn on the 1, add them up, that's 65. That bit configuration of the second one from the left and the last one on the right having electricity, that's what these dark dots mean. These are the only 2 wires that are dark that have electricity. That's capital A. Well, if you know that that's capital A, what's capital B? 66. That's a 64 and a 2, but not the 1. What's capital C? What do you guys think it is? Yep, 64, 2, and 1. Goes right in order. Capital D would be a 68, a 64, and 4, and so forth. So this is how data can be stored, and binary is the basis of storing that data.